This is example 4.3.4. It says a rock is thrown at 60 degrees and lands 124 meters away. How high does it go? So this is a multi-step question. We're going to say, okay, we fire a projectile, we launch it at 60 degrees, and we want to know what this maximum height value is. Okay, so I'm going to call that dy, and we're just going to say max. So this is a multi-step question. The first thing we want to do is we say we want to know what delta dy is. And how we're going to figure that out is we're going to do if that. But in order to get to the point where I can do if that, I'm going to have to use this 124 meters in the horizontal direction. So what we can say is in the x direction, I have the range is 124 meters. I also have that the angle is 60 degrees. And I always have that g is 9.8. So I can use the range equation and I can solve for the initial velocity. So when I do that, I get 124 equals vi squared sine 120, because it's 2 times the angle, divided by g. Multiply both sides by 9.8 over the sine of 120. And when you do that, you get 124 times 9.8 divided by the sine of 120. And you get 1403.2 equals vi squared. You got to remember to take the square root of both sides. And when you do that, you get 37, I'm just going to go ahead and round it and say 37.5 meters per second. Once I have that, that's now going to give me some information that I can use to solve for the maximum height. So remember, we're trying to solve for the maximum height. In the y direction, you know the acceleration is negative 9.8 meters per second squared. You know, in this case, the initial velocity in the y direction is not going to be this 37.5. That's what it's launched at an angle. You can figure out what the initial velocity in the y direction is by doing the sine of the angle. So 37.5 times the sine of 60 that gives you 32.5 meters per second. That's going to be your velocity in the y direction. You have one other piece of information that's very useful, and that's the fact that you have the final velocity. Remember, at the highest point, the velocity in the y direction is going to be 0 before it turns around and starts coming the other direction. So now, if I have initial, final acceleration, and I'm trying to solve for distance, that lets me know that the one factor that I don't have is time. So the equation that does not have time in it is A equals Vf squared minus Vi squared over 2 delta D. I'm going to isolate for D, so we're going to get delta D equals Vf squared minus Vi squared over 2A. We plug in our numbers and we say, okay, delta D is going to equal 0 squared minus 32.5 squared over 2 times negative 9.8. We enter that into our calculator. We say negative 32.5 squared divided by 2 divided by negative 9.8. And we get 53.9 meters. Alright, this is example 4.3.5. It's an elevated target question. This question is a really difficult question. You may see this on a test as kind of the last question or a bonus question, but you will see it on your quest assignment as well. It says a football is kicked upward at 30 meters per second at 45 degrees. If the ball is 40 meters from the field goal post, that is 3.05 meters high. Determine whether or not the ball will clear the goal post. So let's go ahead and draw this situation out. What we have is we have a 3.05 meter goal post, and 40 meters away we have somebody who's kicking the ball, and we want to know whether the field or the ball is going to be above the upright whenever the ball gets 40 meters away. So A lot of people want to use this and they want to say, okay, well, I'll just use the range equation. You can't do that because we're not saying whether or not the ball is going to be on the ground at 40 meters. We want to know what height it's going to be at 40 meters. So we can't use our range equation in this particular case. So what we are going to do is we're going to look at, we have 30 meters per second and we have 45 degrees. That allows us to calculate these two values right here, the velocity in the x direction and the velocity in the y direction. Alright, so let's take a look at what we're trying to determine. We're trying to figure out what the distance is in the y direction at 40 meters horizontal. So we're trying to figure out what delta D is when x is equal to 40 meters. Just kind of keeps track of what we're trying to look for. Okay, so we know because of that, we're not going to be able to use our special case formulas. We're going to have to do the x's and y's. Remember, x only uses this equation right here. V equals delta D over t. The y uses if that. So let's look at our information that we have. We are given, in the x direction, the distance. The distance is 40 meters. We are also given the overall velocity, which allows us to calculate the velocity in the x direction as Vx is going to equal 30 cosine 45. So when we do that, we say 30 cosine 45, we get 21.2. Now, if you notice for this particular example, I also have 30 sine 45, and that would be my velocity in the y direction. Since it's 45 degrees, when you do this, 30 sine 45 gives you the same number of 21.2. That's not always the case. It's the case only because you have a 45 degree angle. So I have the velocity in the x direction as 21.2, and I have the velocity in the y direction, it's going to be the initial velocity, is 21.2 as well. In addition to that, we have the acceleration is negative 9.8. Now, a lot of people will want to take this 3.05 and they'll want to say, oh, well, that's the distance in the y direction. No, that's not the case. Remember, we're looking at the football. We're trying to figure out the height of the football and then compare it to this 3.05 meters. So if you look at what we have, I don't actually have enough information to do if that. But what I do have enough information for is to use the x values to solve for time. And that's what I'm going to do. I'm going to say, okay, v equals delta d over t. Or in our case, t is going to equal delta d over v, or 40 divided by 21.2 meters per second. When you do that, you'll get the time that the ball takes to travel those 40 meters. 40 divided by 21.2, and we get 1.8, we'll call it 1.89 seconds. Okay? When you get that time is 1.89 seconds, this can now cross over to the y-axis. So now I can say, okay, well, time is 1.89 seconds. Now I have enough information to do if that. Remember, I'm trying to solve for distance in the y direction, so d is taken care of. I have initial velocity, I have acceleration, and I have time. I am not interested in final velocity. So I would use the equation delta d is equal to VIT plus 1/2 AT squared. Now what makes these problems somewhat difficult is the fact that this term right here, this VIT term, is not going to cancel out. So whenever I plug in my numbers, what I'm going to get is delta D is going to equal 21.2 times 1.89 plus 1/2 of negative 9.8 times 1.89 squared. So now we're going to simplify this. We're going to say 21.2 times 1.89 is going to be 40.07, and then on the other side we're going to have 1/2, which is 0.5, times a negative 9.8 times 1.89 squared. When you do that, you actually get a negative 17.5. Call it 17.50. So because of this, whenever you take both of these factors into account, you have to subtract, and you say 40.07 minus 17.50, and you get the fact that the football is at a height of 22.57 meters. Now you need to be really careful with this, because a lot of times they'll say, by how much does it clear the goalpost? And if that's the case, you have to subtract the height of the goalpost, which in our case was 3.05 meters. When you do that, you end up that it clears by 19.52 meters. Okay, like I said, this is a very difficult question because it has, you're trying to find the height at a given time. This would be an example of a bonus type questions, but you should be familiar with the ideas that go through it. We've talked about each one of these individually, trying to find components, trying to use if that, constant velocity. This is just one question that puts them all together.